We are going to talk about the last way to solve a system of equations. And remember, a system of equations for our purposes is made up of two equations with two variables in each equation. Okay? And we've seen how we can solve them by graphing. We've seen how we can solve it by substitution. Now there's another algebra method that we can use. So let's say that we're given two equations, a system, here. Okay. And we are told that the solution, so maybe we found it by graphing, maybe we found it by substitution. We are told that x is 2 and y is 1. And that makes sense because if you look at this one, 2 times 2 plus 1 does equal 5. And 2 plus 2 times 1 does equal 4. Because this is 4 plus 1, which is 5. This is 3 plus 2, which is 4. Okay. We can actually add equations and subtract equations. We've been multiplying equations and dividing equations for quite a while now, for the last couple of years. Okay, but we can actually take two equations and add them together, and we add them kind of like the old way that you would used to add, like say a 3-digit number plus a 3-digit number. You'd line up the ones, you'd line up the tens, you'd line up the hundreds, and etc. Okay, here they're both going to be in standard form, if you remember what standard form is. So we're going to line up the numbers on the right, we're going to line up the equal signs, we're going to line up the y's, and we're going to line up the x's. And so if I take this first equation and if I add the second one, 2x plus x is 3x, y plus 2y is 3y, 5 plus 4 is 9, and I get a new equation. Well, it just so happens that the solution to these equations is also going to be the solution to this one. Why? Because 3 times 2 plus 3 times 1 does equal 9. 6 plus 3 is 9. So that property, if we take a system of equations and add them together, we're going to get a new equation that still has the same solution. That's actually important for the method we're going to learn. It actually works the same way with subtraction. If we took the two equations, lined up the x's, lined up the y's, lined up the equal signs, lined up the numbers on the right, and subtracted them, and remember, we're going to have to subtract everything. Well, what's 2x minus x? X. Y subtract 2y. Negative y. 5 subtract 4. Is 2, 1 a solution to that? X equals 2, y equals 1. Well, does 2 minus 1 equal 1? Yes. So if I subtract two equations, I get a new equation that has the same solution. So using this property, we're going to use an algebraic method called elimination to solve a system. Okay? Basically, what you're doing is you're taking the two equations you get in your system. You may have to multiply one or the other by something, but then you're going to add or subtract in such a way that you're going to eliminate one of the variables. When you eliminate one of them, that means you can solve for the other one. This will make more sense when we do an example, such as this. Okay? So first of all, and what I like to do as well, just like we did with substitution, I like to give each equation a number and then just sort of write a quick little blurb about what I'm doing. Let's rewrite these so that they line up vertically. So 2x plus y equals 7, and let's write the second equation underneath. X plus y equals -4. Can you see a way to add or subtract these two equations and it will get rid of one of the variables? Adding or subtracting? If I subtract both equations, or one equation by the other. So what I'm going to do is I'm going to subtract equation 1 minus equation 2. And why did I do that? Because I eliminated one of the variables, which means I can figure out what x is. So y subtract y, those are gone. 2x minus x is x, equals, now you got to be careful with this. This is -7, subtract -4. -7 subtract -4, which becomes -7 plus 4, which is what? -3. You're halfway. You got one of the variables. How would you find the other one? Just like we did with substitution. How would you find the other one, Yamna? Yep. Yeah. Plug x back into one of the equations and figure out what y is. So sub 3 for x, sorry, -3 for x, in one of the originals. Which one would you like to do? 2. Yeah, 2 looks like it's easier. So that means equation 2 looks like instead of x, I write -3 plus y is equal to -4. Solve for y. Add 3 to both sides. Y is equal to -1, and you've got your solution. You can write it again as a coordinate, or you could just write x equals -3, y equals -1. You don't have to write both. Either one is fine. Okay. So that's elimination. Sometimes we may have to do something before adding or subtracting. For example, this. So I'm going to call this equation 1. I'm going to call this equation 2. So I'm just going to rewrite these. I can't add and subtract right now and get rid of one of them, can I? If I add, I'll get 8x plus -10y, or -10y. If I subtract, I'll get -2x plus 2y. So I've got to do something first. Remember, you can multiply equations as long as you multiply everything by the same number, and it's still the same solution. We've been doing that when we were solving fraction equations. Can you think of what you could multiply this by, this equation, and multiply this by? They don't have to be the same number. They can be different numbers, so that if you added or subtracted, one of them would go. Yamna? 3? So which one by 3? The bottom one? Yes. Okay. So what she's saying is multiply, she's looking at the x's. Well, if I multiply this by 5, I'm going to get 15x. How am I going to get 15x here? I'm going to have to multiply this one by 3. Okay? That's usually the easiest way to do it, is look at the x's and figure out what you have to multiply each one by. So when you do that, you're going to get 15x minus 20y equals 35 for the top one. The bottom one's going to be 15x minus 18y equals 24. Now I can subtract them. So what did we do here? We did 5 times equation 1 minus 3 times equation 2. And we did it actually, and I'll just add this to eliminate x. You don't have to necessarily write that. A lot of students find it handy to write something like this before they do it, just so that they're keeping organized. Because algebra there's just so many steps involved in different algebra things that you do. It's good to be organized. So 15x minus 15x. Nothing. Don't have to write 0x or anything. They're gone. What about the next one? Negative 38y. Sorry? 2y? Negative 4y? Negative 2y, I thought I heard. Remember, negative 20 subtract negative. So that becomes plus. So negative 20y plus 18y, yes, becomes negative 2y. Equals 11. So what is y? Whoops. Right. Okay, this time we got a fraction, but that's okay. Because actually when we plug it back in, the fraction is going to disappear when we calculate x. So our next step is to take this, is to sub negative 11 over 2 for x into one of the originals. And it really doesn't really matter, it doesn't matter which one. They're kind of both the same. So I'm just going to say 1. If you want to do 2, go ahead. You're going to get the same answer. Okay. And that allow you to solve for x. So if we do that, we're going to get 3x minus 4 times negative 11 over 2 equals 7. Oh, what's negative 4 times negative 11 over 2? Negative 44 over 2. Is there an easier way to say that? 22. So 3x plus 22 is equal to 7. Next, subtract 22 from both sides and you get 3x is equal to negative 15. Divide both sides by 3 and you get x equals negative 5. So your solution to this system is negative 5 for x, negative 11 over 2 for y, or if you want to write it as a coordinate, negative 5, negative 11 over 2. Okay. Cool. Yeah, that looks a little ugly. Why does it look ugly? What's making it ugly? The fractions. How can we beautify this, as in get rid of the fractions? Multiply this by 6. So 6 and 3 cancel down to 2, so I get 2 times 2x, which is 4x, minus 6 over 2 cancels down to 3. 3 times y gives me 3y. Equals, sorry, I forgot to do this, 6 times 4, 24. That's easier. Okay. What would you multiply this one by? 4. So 4 over 2 becomes 2 times 1, which is 2x, plus 4 over 4 becomes 1 times y, which is just plus y. 4 over 2 becomes 2 times 5, which is 10. Now I'm going to name them, or number them, pardon me. So we can't just add or subtract them right now. We've got to do some multiplying to one or the others, or one or the other, or both. What do you think you could do? For me, I always look at getting rid of the x. Celeste? Yeah. So do 2, sorry, take equation 1 and subtract 2 times equation 2. That will eliminate x. So we're not touching equation 1. So we're leaving it as 4x minus 3y equals 24. When we multiply this by 2, what do we get? Everything gets multiplied by 2. What does it look like? 4x. Careful. Everything is multiplied by 2. 2y equals 20. Okay. So that's times 2. Now we can subtract, and it's going to eliminate the x. Watch your signs. Negative 3y minus 2y.
What?
I'm hearing a couple answers. Negative 3y minus 2y. Negative 5y. Equals 24 minus 20. 4. So y is equal to negative 4 over 5. Now we got to plug that back in. And we don't have to plug it into the original fraction ones. We can plug it into the ones we changed to. So we're going to sub negative 4/5 for y into one of the originals, or one of these. Maybe the second one. So when I do that, I'm going to get, so I'm going to do into 2, solve for x. So that's going to give me 2x plus negative 4/5 equals 10. which is the same as 2x minus 4/5 equals 10. What do you want to do with this one? Really? Yeah, why don't we just get rid of that? Times everything by 5. You could add 4/5, but then you're going to get into fraction addition, and then you're going to have to do fraction division. And that can get very, it's easy to make a little mistake there. So this gives me 10x. 5 divided 5 is 1. So minus 1 times 4 is 4, equals 50. Therefore, 10x is equal to 54. Divide both sides by 10, and I get 54 over 10, which can be reduced to 27 over 5. So that was a bit of a nasty one. Okay. So this time, x is going to be 27 over 5. Y is going to be negative 4 over 5. Or we could write it as a coordinate, 27 over 5, comma, negative 4 over 5. Okay. So I wanted to show you one to get some practice with the fractions, but really the ones that you're going to see the most of are like example 1 or example 3, where you actually have to use it to solve a problem. Just like we did with graphing, just like we did with substitution. So first of all, we got to set up a system. Ms. Wilkes decided to purchase M&M bags and Hershey bars for all of her students. Each M&M bag cost $3. Each Hershey bar cost $2. She purchased 16 of them for a total cost of $41. Somehow I have to create a system out of this, 2 equations with 2 variables in each. What would be my variables? What would be my unknowns? The number of Hershey bars and the number of M&Ms. What would you like to call them? Okay, so you got to set that up first before you write your equations. Now, she purchased 16 of them. How do you translate that? X plus y is equal to 16. The second equation represents the cost. How would you write that? X times 2 or 2x plus 3y equals 41. Okay. And there's your system, and we're ready to solve it. We're going to reach the point where I'm going to say solve this problem using any method you want. But some students find it actually easier to use substitution for this one. But I don't know, I like elimination. Okay, what are we going to do? We can't just add or subtract them as they are. We got to do something to one or the other. What do you want to do? Okay. Yeah, so equation 1 times 2, and then do what? And then what? Yeah. Subtract what? Don't overthink. So you're telling me multiply this by 2, and then do what? Subtract equation 2. Thank you. Yeah. So we're going to multiply this by 2. What does it look like? Okay. And then we're going to subtract equation 2. Well, those are going to go. What are we left with? Negative y is equal to negative 9. So if negative y is equal to negative 1, positive y is equal to positive 9. You just switch the sides. Okay, so we got the number of M&Ms. Now we just need the Hershey bars. Well, that's pretty easy. I think we just sub that one back into equation 1. So sub 9 for y into equation 1. That's a really easy one to work with. Because then I'm going to get x plus 9 is equal to 16. So x is going to be 7. Remember, we're in a word problem here, so we need a sentence. There are 9 Hershey bars. Did we? Sorry, am I wrong? Sorry. So there are 7 Hershey bars and 9 bags of M&Ms. Okay, so we've covered quite a bit of ground here. I wouldn't mind taking the next class to practice each of these methods at the boards, just so you guys have a better idea. But in the meantime, I would like you to, for Tuesday, do this, please. Oops, I didn't put it in. Exercise 4.4, I want you to do. There might be some to omit. I'm not sure yet. No, you can do all of them. So exercise 4.4 for Tuesday, please. All of exercise 4.4 for Tuesday.